Welcome you all to the Spark Research YouTube channel. This is Dr. Vision, the Assistant Professor in the Department of ECE, and we are going to take some questions which has asked in GATE 2019 in this session, which particularly belongs to the unit first and second, that is the modulation techniques, right? So if we will check, then always the one or two questions mostly coming from this particular topics, that is amplitude modulation, demodulation, right? The angle modulation, right? So let's take the question. So in this series here, the question is the baseband signal MT shown in the figure is phase modulated to generate the phase modulation signal phi of t is equal to cos twice pi fct plus k of mt. The time t on the x-axis in the figure is in the milliseconds, right? And this is the x-axis. If the carrier frequency fc is given 50 kilohertz, this is separate, right? And k is equal to already given 10 pi, right? So here all these values. The ratio of the minimum instantaneous frequency to the maximum instantaneous frequency is what? So since this is the phase modulation, one part of the angle modulation, so here angle will vary, that is frequency will vary. So in this question they are asking what will be the ratio of the maximum to minimum angle, and that is the maximum to minimum frequency, right? So first of all, so we will check. So you can use this concept like the instantaneous frequency, that is phi t is equal to omega ct plus kp mt for your phase modulation only. And so we can find out the maximum and minimum frequency, and then we can divide, right? So how can we find? So this is instantaneous frequency. So in order to make it minimum or maximum, we have to take the differentiation, that is d theta by dt. So mt divided by dmt divided by dt, right? So what will be the dmt? Here it will be directly fc, so no problem, fc is already given, and in this component dmt by dt, right? So what is this dmt by dt? That is the slope of this mt function. So basically we have to find out the slope, maximum and minimum. So you can see the maximum slope is in between time 0 to 1, and minimum is 1 to 3. So we can find out this minimum and maximum, and then we can get the value of the, then we can get the value of the instantaneous ratio of the instantaneous frequency, that is maximum to minimum, right? So as per answer key, your answer should be in the range of 0.74 to 0.76. So before going to discuss about this question, let's take the basic concept of the phase modulation, since this question belongs to the phase modulation. So here is your modulating signal, and and message signal, and this is the carrier wave, and this is the phase modulated wave. So you can see here the in this phase modulation the frequency is varying. Here it is very high, here it is low. So what is the ratio of maximum frequency to the minimum? This is the question, right? So how can we find this? So here you can find this angle is there, and instantaneous frequency you can find using this equation, that is theta t is equal to omega ct plus kp mt, and this is the final equation for your phase modulation technique, right? You may also rewrite like this equation. Okay, so here let's find out. So instantaneous frequency we can find from the previous formula, that is d theta by dt we can make. So d theta by dt, so omega is there. So if you will remove that omega, then it will twice, omega is equal to twice pi f. So f is instantaneous is equal to 1 pi twice pi, and d theta by dt. So it will be equal to fc and plus k of dmt divided by dt, and definitely k is there. So 1 by twice pi will be also added here, right? So now question is that what will be the maximum and minimum slope. So in this question itself, this the empty slope is given. So here what will be the maximum? So maximum is like how will you find slope? So slope we can find y2 minus y1 divided by x2 minus x1. So what is this y2? That is minus 1, and y1 is minus 1, and divided by the 1 minus 0. So we will get that maximum value, that is 2000 volt per second, right? And similarly for minimum we can find from in between 1 to 3, that will be minus 1 divided by minus 1 divided by 3 minus 1. So this will be 1000. right? So once we'll get these values, maximum, minimum, then we can find out the ratio, right, corresponding to the frequency. We can put the values here, that is k dmt by dt, this slope, and we'll get the value of the maximum and the minimum instantaneous frequency, and then we'll get the ratio. So final answer will be 0.75. So let's see the more calculations, more details about this calculation. So as per the formula, your first, your frequency is equal to the d theta by dt and twice by also, and fc will be the carrier frequency. So in this question, fc is already given, that is 50 kilohertz, and k dmt, right, and divided by the dt. So what to do here, first we will target to find out the dmt divided by dt, because this is unknown quantity. All remaining quantities, fc is given, k is given, twice pi is also the fixed quantity. So let's find out this dmt by dt, right? So what is this dmt by dt? This is nothing, this is the slope only of this, right? So in question only, your mt is given, so we have to find the slope. So maximum slope is in between 0 to 1, the time I am talking, right? And minimum is in between 1 to 3, right? So get the maximum slope, that is slope maximum, that is in between 1 to time 1 to 0, and you know the y axis, that is minus 1 to 1. So you can get like y2 minus y1 divided by x2 minus x1. So this is the maximum. Similarly, minimum you can get in between 1 to 3. Again, use the same technique, minus y2 minus y1, x2 minus x1. So you will get the slope. That is, slope is nothing, slope is volt per second, right? After getting the value of slope, now you can put it here, and then you can get the maximum instantaneous frequency, that is 50,000 fc, and then k, that is 10 pi and twice pi divided by, and this is the, already we got the maximum value, that is 2000, right here. Put the values and get, it will be the 60 kilohertz. Similarly, minimum, now again put the value, dmt by dt is equal to 1000 minus 1000, and get the value. So 50,000 plus k is equal to 10 pi twice pi, and y minus 1000 is equal to, now you will get the 45 kilohertz, right? So now finally take the ratio of minimum to maximum, that is 45 kilohertz divided by 60 kilohertz. So finally your answer will be 0.75, right? So that's all in this session. Thank you to join. If you have any doubts, please drop your comments.